plastic. And now I'm happy to share some interesting new serial applications. But when I was asked by Houston to if I can give the presentation again, I said, okay, I just take the old presentation, which I showed during China Plus. But then I realized that in the last 6 months, maybe a bit more, we had so many new great applications I'd like to share with you. So yeah, I had to do more or less a completely new presentation. So one very important field, and it was already mentioned before, of course, the battery electric vehicles. It's like a perfect match, polyketone and battery electric vehicle applications. And there are good and many reasons for that. Looking into thermal management of a battery electric vehicle is completely different from combustion engine. In a combustion engine, you need more or less to cool the engine while the car is running. Temperature control the engine. In a battery electric vehicle, you also need to take care of the temperature of the battery while it is standing outside in winter times. So it must not go below a certain temperature. You must control the temperature in your fast charging unit. You must control so many different converters, inverters, and on top, then you have also the heating, ventilation, air conditioning. So you see immediately that there are many jobs to be done, and therefore you have. I already mentioned the system in use time in a battery electric vehicle is much different from combustion. So in combustion engines, we test for 3,000 hours. Now, if you look into battery electric vehicles, 15,000 would be nice. They go even to 30,000, which is already 10 times the in-use time compared to a combustion engine. And we have already customers asking for even more, for 45,000 hours, 15 times the time of a combustion engine. So that makes it necessary that you use really the right material. And polypropylene, some say polypropylene, creeps a lot, and there are reduced polypropylene types, but after such a long time, there is creep. That's just the nature of the polymer. Yeah, it's hot-good oil. So therefore, yeah, we see 0.6 or even more expensive grades like PPA or PPS. So we have combined it with sealing ring and with a clamp. But in the end, you can really focus on mechanics and on toughness in this area, on price, and also with our PK VM GF30 Black, many applications in all different areas. And the reasons why polyketone is used are,
and it has already been mentioned. So in that specific case, it's heavy-duty caster wheels. So caster wheels are, so to say, made with nylon 6 since decades, and it's the standard material that's used widely. And we had a customer, family-owned business, smaller privately held customer that is acting as an OEM. So they do their own development, they do the manufacturing, they do the selling, and they sell globally. So they are one of the market leaders on that, and they had an issue with their heavy-duty caster wheels with nylon 6. So we had a chance to test polyketone against it in the same tool. We were supporting them several days with molding trials, and we could speed up the cycle time by 50%, so which is a huge step, and you've already seen it, that it's possible, and I will explain later a bit why this is possible with it. But this was not the major driver for the customer. It was the driver that the mechanical properties that they had been testing then with this application. So that means that all the lifetime testing, it was a fuse test, maximum stress test, it was maximum load test, it was boiler fatigue, and everything else, all the long-term testing that they have done. And there they found, depending on the test, an improvement of 30 to 40% over their nylon material that they have been using since decades. So now they are stepping in for that heavy duty caster wheels and replaced it by polyketone. And this application will be multiplied We've already seen it. That is some kind of number one application in the automotive industry is high voltage connectors for e-mobility. So typically the materials are used are nylon based, so nylon 6,6, some PPT, also some PPA materials are used as well as polyethylene. Standard material is glass fiber 30 with a flame retardant system that enables to reach B0 plus orange color, which is needed for that to make it optically clear that this is high voltage applications. And polyethylene for me, polyethylene is the superior material because it has significantly higher toughness than all the other materials that are used. And I've made a comparison with the strain and break. You can see that with various materials that are listed, so not only these two materials here that are used, but I've also just for comparison added a few others, and you can see that the margin that the material gives after the glass fiber and flame retardancy is that you have twice as much as elongation at break. And typically, when material is aging over time with heat and time, so the material and parts typically break due to brittleness. And here you have a huge safety margin in terms of long-term application as well as for all the clips. So it's twice as much as every other materials. For fiber trays, so this is pretty much a big topic in Germany that we are building our glass fiber network for internet to get a broader range. The part we are talking of is about this one, this flap here. So there are many put into that device, and then the whole network is then used to distribute that within buildings or within communities. So it's a highly complex application. In total, the whole assembly, and we're using here a unfilled polyketone with just with flame retardancy liquid 0. It's a custom color, so it's mass colored, special white for that customer. And the combination is PFAS-free and allergen-free. And the customer was using in the past predominantly ABS material. This first try, but with the new requirements for that application, ABS did make it. So we had a chance to discuss with him and introduce also polyethylene, which was not known to him. And also here, we supported the molding trials and could speed up the cycle time by 50% with ABS, and this is a thin wall part, so with just 1 millimeter. And the caster wheels, for example, were thick wall parts where we are talking about cycle times of minutes, since the parts are several centimeters thick. So, and for the customer, it was the combination of the mechanical performance. So a lot of still a lot of sharpness is left over. So with that combination, unfilled, you have 40% of elongation at break with the material still with B0. So that was one point for the material, yeah. So they've done their extensive testing, and now they are scaling up, and they build a new four cavity tool, to my knowledge. And what I heard, they should be in contact with you. As far as I heard, that they are switching to a full hot runner system, and it will be a full hot runner system. Coming to the molding conditions, we already heard it. So we've done a calculation where we did a basic calculation here on the example with a 2 millimeter wall thickness, just to see what the minimum cooling times is in a comparison of polyketone versus various other polymers. These are just unfilled polymers. In the next slide, we have 30% glass fiber. And you can see what already has been mentioned, that polyketone is about the fastest cycling materials. And there are two reasons for that. One is the thermal aspects, that the heat transfer is quite quick. And the other one is that the speed of crystallization of the material is exceptionally fast. And that makes it a really super fast cycling material, which adds besides the performance and properties of the material, adds also a big step in economical benefits that the customer can get. But this needs to be, so to say, supported in the molding trials, really to squeeze out what's possible. And we've proven several times that we can speed up the cycle time.
So typical module, made of palm would last 2 to 3 months. Again, cut resistance and drop impact that could potentially, be cause of replacing it. Now that paracetic acid was being used, some of these modules were breaking in as little as 2 weeks. Increasing manufacturing cost, downtime, and then a new concern with this polymer fragments mixing with the meat because they were breaking so regularly. So this is where we got involved with our customer. They brought the problem to us and said, we need some help. Through the design funnel, we started looking at it and really the chemistry behind the problem that they brought to us with paracetic acid. We can see how it readily breaks down the carbon oxygen bonds in palm, but has no effect on POK. Oops. Continuing through the design funnel, POK has a great regulatory approvals. Didn't have a concern there. Like you said, they meet all the FDA and other countries' food contact. We did some studies to show that POK has superior wear and friction performance. And as you can see on here, we definitely improved the wear resistance and at different rotational speeds that the customer would need. And then mechanically, MK had mentioned earlier, POK has 3 times the toughness as palm. So really looking to be a good candidate for next steps. And so we did just that. We went to our customer, we sampled with them. Parts came out looking great. Dimensional requirements such as pitch and length are very important as these fit together. And we were able to meet those without needing any mold modifications due to its similar shrink rate. And then, of course, the resistance of the sanitizer appeared to be good to move forward. So the next logical step was to get this belt in production to see how it was going to perform. So as they were mentioning, palm was lasting about 2 weeks. So we started calling about that time frame to see how was it going. Things were great. Weeks turned into months. And finally, at the 9-month mark, the customer couldn't believe how well it was performing and decided to just take it offline and replace it just because they thought for sure this thing was going to break eventually. It did not. We also had some unexpected benefits of polyketone. So we mentioned cleaning happens every day. And with the palm, protein residue would stick to the belt. So that led to a little bit more elbow grease needed to clean these belts. But also, as you can see on the bottom side there, they were losing products. So improvement there because, like I said, it did not stick with the POK. Cut resistance was improved. They never had to replace a module because the cut marks were so severe that they were worried about bacteria. So we reduced that. And then, of course, because we didn't have any breakage with the polyketone, the concern for contamination was completely eliminated. And then on the molding side of things, we were also able to reduce cycle time by 15%. So for the customer, polyketone was truly an amazing problem solver.
Torch and grit test, one of the most demanding thermal tests in industry, and a standard required by global leaders like HKMC and UL. Here's how it works. We take 2 millimeter thick sample of our material from the 6 millimeter from the torch away, and we blast it with a torch flame heated to incredibly 12,000 1,200 degrees Celsius. The test runs a 20-second cycle. For the first 15 seconds, they're gonna be only torch, but the final 5 seconds, we add abrasion aluminum grits into flame to simulate the high energy particle spray from exploding cell. The target is simple but critical. To ensure absolute rear side stability for safe inclusion design. And the pass-fail conditions are strict. Any hole, any burn through, or any ignition on the rear side. So let me show you the demonstration video of it. Okay, now I'm going to show you a video of the torch and grid test featuring our 7500 TFR grid. To give you a clear comparison, the video will show two materials side by side. On the left is our TFR grade, will be TFR grade, and on the right side is a standard flame retardant material, a polyamide 6 with 30% glass fiber rated to B0. And both specimens are, as I said before, 2 millimeter thick and 1,200 degrees Celsius. Flame gonna be 6 millimeter back between the specimens and the torch. And let's watch and how it will work. Oh. Here is the demonstration video. I'm going to skip the introduction about our grade. Just to make sure, this is our TFR grade, and this is the nylon 6 flame retardant grade. And here is our specimen. It's a 2 millimeter thick, and the distance from the torch and our specimen is 60 millimeter. And for 15 seconds, they're gonna be only flame over here, and for 5 seconds, they're gonna be flame and grit. That's a one cycle, and let's see how long they endure this test. This is one cycle. After 15 seconds, there is a kind of aluminum grit over here right now. And now it's cycle 2. And repeat for 15 seconds and 5 seconds section. And as you can see, the nylon single flame retardant grade had a hole already during the cycle 2. So we stopped it. But this is polycatone grade, TFR grade. And now it's cycle 3. Let me just skip some scene to how long it endured this test. So it's cycle 5, cycle 6, cycle 8, 9, 11, 13, 15, 17. It's a kind of char layer of polycatone. 19 and 20. Even cycle 20, there's no any hole or no any flame in the backside. And let me show you the backside of this specimen. Here is the backside of it. Yes, flame is over here. And here is the backside of the specimen. This is during the cycle 1. No hole at all. Just let me show you the cycle 2 to show the hole in the here. Yeah, now it has a hole over here, flame in the backside. It means that this grade is failed. This is polycatone TFR grade. Let me skip to cycle 4, 6, 8, 10, 13. Still there are flame over here in grid, but there are no flame or core at all. And yeah, until 20 cycle, there is no hole. I don't know, let me show you the. Here is the result of the test. Can you switch to? Yes. This is the still image from our torch and grid evaluation. The specimen on the left is the front.
Polyketon. Then we are telling two stories. One is that engineering commodity resin, which is If5 material, and super engineered plastic material. So number one is that if the material have a problem, issues, or big troubles, then we are a solution provider. And the super engineered plastic sometimes too expensive with over engineering factors, and we give customers as a reasonable price wise, as a moderable performance, then customer optimize the engineering factors and reduce the cost. So first is that polyamide, lower water absorption, price or stability, stacks or shortage, and POM, formaldehyde-free, lower density, PBT, better hydrolysis, higher impact strength, and polycarbonate, better. What polyketon? How? So first, polyketon density is 1.24, PBT 1.31, POM 1.41, nylon is 1.17. So its position is here. Tensile strength, polyketon is around 58 to 60 megapascal. So something like soft than POM. And elongation and yield, polyketon is more than 200%, very high. And hardness looks like soft versus heat deflection temperature is very similar with nylon W6, and toughness similar with the polycarbonate. And polyketon is tough and high impact and competitive with engineering resin so much. And bottom table here, we can see 2 points. One is that impact strength, and the another one is that changing properties nylon. So polyketon as unfilled base resin, 15 kilojoule per meter square unfilled base resin versus nylon 4 to 5, PBT 5, POM 6. So 3 times higher as unfilled base resin. And nylon, very good material, but it absorbs water and change a lot. So as a dry 17, 19, but after wet 360, 370, but polyketon 200%, always stable. And flexural modulus, unfilled base resin around 1250 megapascal. Nylon start 2600 in dry, but down in wet 600. Very change. That's why we are telling polyketon is here, and you have a problem, then we can give you the solution. So as a summary, nylon high moisture absorption needs conditioning for the impact strength. POM formaldehyde emission plus low acid chemical resistance is not so good. And PBT, a limited hydrolysis resistance, and ketone is telling you 9 points for the performance, chemical resistance, barrier property, impact, water resistance, heat resistance, HDT, and the touch and grid of the frame, and resilience, spring back toughness, abrasion resistance, safety, non-toxic, and MVH performance. Last year, our mix sales performance by items. Number one was automotive parts for the connector electric vehicle components and some the another cooling module system. Number two for the home appliance gears and housing, mostly replaced from the nylon versus glass fiber, water absorption and voltage happen. And during operating the vacuum cleaner in home, making sounds because of the hot steam is the typical lifestyle these days. And nylon absorb water, making noise a lot. Food conveyor belts, that is excellent for polyketone, replacing from homopon and copon both. And toy parts, cosmetic packaging and pump, water purifier feeding, industrial roller caster fuel, and lastly, oil and gas pumping components and pipes.
View about polyketone. Polyketone can be categorized based on the melt flow index and melt temperature. Our main grade is the melt temperature is around 220. And we have 5 grades from low viscosity M130 to high viscosity M730. We also have a special product like M640, which has a higher melt temperature, and M410 and M710 is the lower melt temperature. By adjusting the propylene content. This is the compounds grade we have right now, and we have glass filled material, flame retardant material, and lubricant material, and flexible tube application. In case of glass fiber reinforced material, the polyketone can be reinforced with up to 50% of glass fiber. And we also have a new EU directive grade for water application. And we also have an improved processing grade M33, AG6A, and B2. Also, recently we got a lot of requests from the flame retardant grade for application like electric vehicle. So we have a portfolio of flame retardant grade across various thickness. And we also have a wear resistance grade. And naturally polyketone has a good wear resistance. So by adding silicone or TPU or milk jet, we can improve further of our wear resistance potential. Current level is around 3.1. It means that if the 3.1 kg of CO2 is emitted when we make a 1 kg of our polyketone. In case of P6 and P6, 6.4 and 6.7 double. So it is a very good advantage when you use the polyketone to reduce the global carbon footprint. Another thing is that the polyketone has a higher thermal diffusibility coefficient. So as I talked to you before, you can reduce the total cycle time. And this is the example of the real application. We reduce the cycle time by reducing the cooling time. The example is the PN, PBT, and polyamide replacement from 29% to over 55%. Weakness, so we have 3 weaknesses like the black specks and UV degradation and the discoloration. To improve this black spec, we should keep the melt temperature 20 degrees C above our melt temperature of our polyketone. And also, definitely, the residence time is not that long, it will be better. And we have to purge nitrogen when you do the injection molding and extrusion molding, then it will be very helpful to reduce the black spec issue. To improve the UV degradation, we normally use the UV stabilizer, UV 1164, or carbon black, or TiO2. In case of discoloration, we normally recommend the dark color like black, brown, green. But recently we are focusing on another color. So we are now testing with the AF color in Germany and some master batch company in Korea. So we are now doing the test for 85 degree C and 85 relative humidity, because our